Saxon Advanced Mathematics, Lesson 37. Greetings, ladies. We have two topics today. They kind of go together, but they're distinct, and I'll help you understand the difference. Let's dive into the first part. We're going to talk about lines, so super simple. And in the past, we've always defined a line as a series of points, right, that extend in a perfectly straight manner infinitely in both directions, right? Those are tiny little points. I don't know if you can see them. But there's another way that we can think of a line, and that allows us, once we get that understanding in our head, it allows us some interesting calculations. Let's say we have a point A right here and a point B. Let me make them underneath each other. That'll be easier. Okay, ignore that. All right. We can define a line as all the points that are equal distances from A and B. All right, so let's take, there's the point right directly halfway in between them. That would be a point on the line, right? Because this distance and this distance are the same. But what if we said, okay, let's go way down here and put a point, and that will be the same distance. We say that those two are the same. Let's say that these two are the same also. We'll put some lines on here. And then let's pick another point right about, where would it be? Maybe about here. I'm eyeballing this. We could actually measure it though by making sure that that segment and that segment were exactly the same. I'm kind of doing this in reverse order. So if we kept doing that and then connected all the dots, that's another way that we could define what a line is. Okay, so that is called the, oh, you're gonna love this, the locus definition of a line, okay? And that is that it's all the points that are equidistant from two specified points. Okay, locus is a Latin word that means place, or it's helpful for me to think location. Okay, so all of these points are located the same distance from A and B. Now, that allows us to play around with some fun little algebra problems that go like this. Write an expression for the distance between these 2 points. Those are commas. All right. Well, just a second. This doesn't really relate to my picture. This is warming up for a harder one. So let's just do this problem. This is just using the distance equation, okay? What we're gonna do is we're gonna take this idea and the distance equation and put them together, but John's allowing us just to practice the distance equation first. So these are our 2 points, and we remember what the distance equation looks like, right? Distance equals the square root of, and then this is the version of it that I like to memorize. Because these chunks come right out of our old friend, the slope formula. So let's just use what's already in our memory. We know that it doesn't matter which order we do these in, because once we square the difference, it's going to be positive no matter what. So we can change the order even within the same version of the equation. We could make this one x1 minus x2 and this y2 minus, sorry, my mouth is not paying attention to my brain. We can change the order of the subscripts if we want, because any negative values will be turned positive in the squaring. We can add these in either order. So some people may use a different version of the distance equation than you're used to, but this is the one I want you to memorize because it is easiest to remember. So now all we're going to do is we're just going to remember how to plug values in. I'm just going to name them x1, y1, x2, y2. Let's make it easy, right? Just do them in order. So now let's substitute things in. The distance equals y2, that's y, minus y1 is 2 squared, plus x minus 4 squared. Okay, and this is the answer to this problem. John just wanted to give us a little bit of practice of remembering how to plug points into this, especially points where there are letters mixed with numbers. Now we're going to bring these two ideas together in the next problem. And it goes like this. Find the equation of the line that is equidistant from, and then it gives us 2 points. Write the equation in slope-intercept form. Okay, let's take a look at what the points are for 2 and minus 2 minus 3. Now, John did not tell us to graph it, but to help aid in understanding, I want to draw a picture. Whenever you're struggling with a problem, it always helps to draw a picture. All right, let's put a few marks in on our x-axis. We'll use the lines of the notebook paper for the y. 4, 2, and minus 2, minus 3. Okay, so those are our 2 specified points. And we're using the quote-unquote locus definition of a line, which says that between these 2 points are an infinite number of other points that form a line, and each point on the line is the same distance away from our 2 specified points. Okay, what does that even mean? Well, let's just draw a picture, and I'm approximating, so you have to use your imagination a little bit. We're imagining that that's the line that forms in between them, okay? We're supposed to find the slope and the intercept of this line. The way we're going to do that is we're gonna say, okay, well, this distance from this point to the line has to be the same as this distance from the point to the line. So what we can do is we can call this point x, y, and then we're gonna say the distance from here to here, which we'll write inside of there using the distance formula, this distance should be the same as this distance, again, using x and y as the second point. So first we're gonna compare, we could do it in either order. Let's do it. We can either do it in the order that our picture suggests, which is using this one first, or we can do it in the order of our original points. Let's do it in the order of our original points. So this will be x1, this will be y1. We'll call this x2 and y2. These are going to be equal to each other, so we know it's going to be something squared plus something. I'm going to rewrite my distance formula just so I have it right in front of me. It is y2 minus y1, oops, not squared, subscripted, squared, plus x2 minus x1 squared. So that's what I'm filling in here. The first thing I'm doing is comparing this point and this point. That will give me this distance. There's going to be a variable in it, but we're going to be able to solve for it, is what I'm saying. Okay, so y2 is y2. minus y1 is this value, 2. x2 is that value. X minus x1 is this value, 4. Okay? So this expression represents this distance. Now let me just switch colors to help us keep our heads on straight. Now we're going to do this distance. Okay, I'll change it over to purple. Okay, so this point is this, and we're going to compare that also to this point, right? That's the name we made up for that guy right there. So we'll use this same structure, this same formula, and it will be, this is still our y2s, and these are our new x1 and y1, right? We're not using those anymore. They're in here. Now we're using this second pair to help us find, this is the minus 2, 3, so this is actually this side, right? Okay, so y, and then it's minus 3, so it's y plus 3, and x, and this again, it's minus in the formula, but it's a minus sign here, so it will be plus 2. All right, how do you like it so far? Did you figure out how we got all those numbers in the right place? Oh, we did good. Okay, now we're ready to do some algebra. All right, let me just do this. This is the green side. I wrote it in blue, but this is how we found the green side. This point and this point gave us this side. This point and this point gave us that side. Right? This is this one. And this is that one. Okay. Now we're ready to do the algebra. The first thing we're going to do is square both sides. That'll make the radical signs go away. Then we'll have, oh, I don't need the variable on this, or the subscript. Then we'll have y minus 2 squared plus x minus 4 squared equals y plus 3 quantity squared plus x plus 2 quantity squared. All right. That's better. I feel much better about it. Now what we have to do is square each of these binomials and write it all out. So we're going to have a trinomial for each one of these. That's going to be dramatic, but here's the thing, you guys. You're good at trinomials now, and I think you can do these in your head. So we don't have to write this all out with a ton of multiplication steps. So I'll just remind you that when we convert this into a trinomial, it's going to be, the first term is just going to be the square. The last term is going to be this number times itself, so it would be plus 4. And then the middle term will be this value added to itself. So times 2 is a way of thinking of it. So that will be minus 4, and then we put the x there, right? So we could have done this as a multiplication, but it becomes sorry, I'm just looking to make sure my answer is in here. Yes. Beautiful. Okay, now we'll do this one in our heads. Sometimes this gets a little crazy because we have x's and y's. Just keep it straight. We don't mingle them at all. It's fine. Okay, so here we'll have x squared, and then this will become minus 8x, and then we multiply it plus 16. All right, so there are those two. Now let's go ahead and do these, and you can practice doing them. I won't talk, but just go ahead and do it in your head. Follow along with me, and then we can compare when we're done. Okay, I'll give you a minute to catch up, and then let's see what we can do with all of this. Let's double check. I'll read the whole thing off. Make sure you have the same as me. Y squared minus 4, this should be a y, minus 4y plus 4 plus x squared minus 8x plus 16 Look, I did it again. Y squared plus 6y plus 9 and x squared plus 4x plus 4. Okay? If I made any mistakes, I could compare my answer to the answer in the book, but John's done it in a different order than me, so it would take me a week to sort it all out. So let's just bravely storm in and we'll see if we got it. Now, we need to simplify this mess, don't we? So let's do this. Let's take care of the fact that we have a y squared on both sides and we have an x squared on both sides. So if we subtract y squared from both sides, we clean all that up. And if we subtract the x squared from both sides, we clean all that up. So now we're left with minus 4y, and then let's add the like terms. I can combine that. But I'm going to do minus 8x plus 20 equals, here's the y, 6y plus 4x plus 13. Okay? Yes. Just glancing at my book. What we're aiming for, remember, we're trying to get the equation of this line. So what we're aiming for is to get it into that format. So let's do this. Let's swim the y this way and let's swim the x's that way and see what we get now. So we'll bring this 6 over here and then we'll add the x and we'll subtract the plane number. All right, so that takes care of that. I'm just double checking to make sure. There's a lot going on in this, isn't there? So then we get minus 10y equals 12x, and that would be what? Minus 7, right? We're almost done. The last thing we need to do is isolate this y. So we're going to divide by minus 10. All three terms, and we will get, for our final answer, this cancels. Where should I write it? I'll just write it in this space here. Y equals, this will reduce, minus 6 over 5x. That becomes plus 7 over 10. So you guys, what we did, and P.S., we did it correctly. I'm really excited that I didn't screw that up. What we did was we found the equation of this line that before we were only guessing at. It has an intercept of 7 over 10, and it has a slope of negative 6 over 5. You guys, that was really good, and I'm proud because this isn't a bad approximation. Right? Because it's just a little bit less than 1. Well, mine's a little more than 1. And then it should go down 1 and over a little less than 1. So my guess was pretty darn good. All right? That's kind of cool and kind of fun, isn't it? Let's do one more. And again, remember, what we're doing is we're given 2 points and we're using this locus definition idea to come up with the two distances that we compare and solve to find that line. All right, so we're trying to find the equation of a line. To put it into mathy terms, what we're doing is we're finding the equation of the line given 2 points using the locus definition of the line. Okay? Let's do another one. This is 37.3, and then we're going to switch to the second topic after this. Find the equation of the line that is equidistant from the points 0, negative 4, and 5, 2. Write the equation in the slope-intercept form. Slope-intercept is The reason it's called SlopeIntercept is because it shows us the slope and the y-intercept. We're going to talk about the other forms in an upcoming lesson. So if this sounds kind of new to you to be talking about the slope-intercept form of the line, John's laying some little Easter eggs for us that we're going to be exploring other ideas. Okay, so this is just like the last problem. These are our 2 points. Let's graph them just to help us understand what's happening. Zero, -4. Let's make that our green point. 0 and -4. That's our green point. This poor green marker really has just about had it. And then our purple point will be 5, 2, 1, 2, 3, 4, 5, 1, 2. Okay, so they're not too far off from where we were last time. So we're just gonna guess that our line is gonna look kind of like the last one. It's gonna go roughly through there. Ooh, look at that wobble. All right, and so what we're doing is we're saying we're picking a point on that line and we're gonna draw a line from the green point to that point and from the purple point. Now my picture does not make these look very even, but we're saying that these are the same distance, okay? My graph is just a little skawonky. So what we can do is we can say that this distance should be equal to that distance. This is our purple pair, all right? So let's do I'm not gonna write all the numbers in this, but I'll at least make the radical sign in green. Okay, so this we'll call x2, y2, but we'll just write x and y, okay? This is the notation for our formula. This is the actual value we'll use in plugging it in. Just like up here, this is gonna be our x1 and our y1 for the first pair, but we're not going to write x1 and y1. We're going to write 0 and -4. This will be our x2 and y2, but we're not going to write that. We're going to write that. Okay. It looks like this. We know that. And then it'll be equals, and then we'll do the purple one on this side. Just getting everything all organized so I know where I want my numbers. And then let's write down the distance formula one more time. D equals the square root of y2 minus y1, quantity squared, plus x2 minus x1, quantity squared. There, I'll draw an arrow because I ran out of space. Okay. Remember that the order we put these things in really doesn't matter that much because once we square it, it all turns out beautifully. But we'll still be organized and neat and we'll follow this format because I don't like to just mix it up. All right, y2 is first, that is our y, minus y1, that is a negative number, so this becomes plus 4. Then we have x2, which is our plane x, minus 0. Okay. Over here, now we're going to switch and we're going to use still those as our 2 values, but now we'll switch and use these as our 1 values because we're trying to find this distance. Okay, so y2 is plane y minus y1, which is 2. These are positive values, so the minus sign from the formula will carry through. Plus, x2 is plane x, minus x1 is 5. Okay, we're set up. We're ready to start algebraing this. The first thing we want to do is square both sides. Technically, we would put quantity signs around that whole big beast. Then that leaves us, we'll have each of these quantities squared. Let's just do that in one big jump. We'll take away the radical signs. We're canceling them out when we're squaring them, but then we will expand these binomials as we go. So this will be y squared plus 8x plus 16. And then notice what happens here, x minus 0. Well, this is just x, so we can write this as just x squared, right? There's no binomial there. X minus 0 does nothing. Equals y squared minus 4x. I always do this, you guys, and I know I've done it in past years too. I just automatically write an x there, and that's wrong. So I did it again. Okay, minus 4y plus 4, right, because we square it, plus x squared minus 10x plus 25. So there are our 4 binomials blown out in their squaring. Now, it will always work out this way, you guys. We can subtract the y squared from both sides, and we can subtract the x squared from both sides. Those are always going to fall out. And then, at the same time we do that, we'll move the y's to the left and the x's and the plane numbers that way. So I'll keep the 8y. I will subtract the 16. We'll put it over there with the 25. Then I want to bring this y over, so I'm going to add 4y. So this becomes 12y. This cancels, this cancels, this cancels. Okay, this side's all cleaned up. Now over here, this cancels, this cancels, this cancels, and I will have minus 10x, and then let's see, I'll have 29, right? 4 and 25 gives me 29, and then I'll subtract 16, so that will be plus 13. Make sense? And then our final step is to isolate the y, divide by 12. And we will get y equals minus 5, 6x plus 13 over 12. And that is the right answer. Whew. Kind of a workout, but a really fun way to say, you've given me 2 points. And you know, we know another way to do this, right? We could use the actual slope formula, and then we could solve for b. We know how to find the equation of a line given 2 points. But this is just a different, we're starting from a different philosophy, and what we're saying, oh, well, we can also find it by measuring the distance between each of our points and some imaginary point on the line that we know is there. And we can use the distance formula to find each of those lengths, set them equal to each other, solve a big crazy thing, which has got to make you feel smart. And then we're done, okay? So that is what we're finding is the slope of the line that exists between those 2 points. And P.S., we don't do it the same way. When we've done this in the past, we've been given 2 points that lie on the line. Here we're given 2 points that lie off the line and told that the line lies in between them. So these points represent something very different in this kind of problem than the ones we've done in the past. Now, the next topic, our final topic for this lesson, and it's fast. That's the bulk of it. Part B is called the Midpoint Formula. And it's super easy. Let's say that we've got 2 points. Let's just dive into there's a bunch of theoretical stuff, but I don't think it's helpful. It says find the coordinates of the point halfway between minus 2, 6 and 4 minus 10. Okay, let's graph it just so we can see. Notice that like in the previous problems and this one, we're not told to graph it, but a graph usually helps us understand. So I recommend that as you're coming up to speed in these problems, go ahead and draw the graph so you can be really sure about what you're doing. But once you feel like you're cooking, you don't have to draw the graph anymore. Okay. These points are kind of extreme. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, well, that's fine. Okay, -2, +6, and 4, -10, way down here. That is not the straightest graph in the world, but it'll do the job. Okay, so this is 4, -10, and this is -2, 6. All right. What we're being asked is, okay, imagine a line. Okay, we're not being asked to find the equation of the line that lies equidistant between these 2 points. We're not, which we just learned how to do, to find the equation of a line that lies like that. We're not being asked to find the equation of the line that the 2 points lie along. We've done that in the past. We know how to do that. What we're being asked is to find the point that is exactly midway between these two. And that's assuming that this segment equals that segment, right? It's midway between them. The way that we do it, the little formula is so easy. That's it. We just average the points, okay? And that will get us to, oh no, we add them, I'm sorry. We add them. So the order that we do it in does not matter, okay? It doesn't matter which pair we call x2 and x1 because we're just adding them together. So what we're gonna do is we're gonna add the 2 x's, so -2 plus 4, and then we're gonna divide that by 2. That will be 2 over 2. So that tells us that of this point, x equals 1, because this is our x midpoint, right? We took the 2 x's. For y, and technically I should put a colon there, not an equal sign. The y value we'll just use this one, 6 and -10. Divided by 2. So that equals -4 over 2. And so our y value is -2. And so what that tells us is that the coordinate of this point we calculated as 1 -2. And even given how wonky my graph is, look, we pretty much nailed that -2. The 1's a little off, but you can see that with a more carefully drawn graph, that probably would have been quite exact, okay? So this is our answer. This is the best way to write it. It's not necessary to graph it, but again, as you're building your understanding, it really helps. These two are called the midpoint formulas, and I want you to take a minute right now to add them to the back of your book. The distance formula should always already be back there. Make sure you do that. Let me just say one more time on this, that last time in the past, we have used the 2 points to find the line that both of the points lie on. This time we're given 2 points and we're finding a different line. We're finding the line that goes exactly in between them. Okay, so even though we've done this before where we've taken 2 points and found the equation of a line, it's a different line than we're finding now. Okay, I hope that makes a bit of sense. Next lesson is a fun and completely different one. I will see you in lesson 38.